Working with lists, dictionaries, and functions for customer analytics. This lesson will help you analyze real market research and customer survey data using Python lists, dictionaries, and functions. You will learn how to manipulate customer data, group results, summarize ratings, and generate actionable insights. These skills are crucial for creating effective reports that drive business decisions. By the end, you will be able to structure and process customer datasets to answer real business questions. Running the cell now. Before we begin, let us set up our environment so we are ready for customer analytics. We import the warnings module to suppress any unnecessary warning messages. We configure Python to ignore warnings, helping to keep our output clean. We import OpenML for accessing real-world market research datasets. We import Pandas, a powerful tool for handling customer data in tables. We import NumPy, which provides support for numerical calculations. Running the cell now. You are set up to work with real and synthetic customer research data in the following examples. About the Customer Satisfaction Survey dataset. This dataset contains real customer demographics and service usage information. Each row represents a customer's profile and their satisfaction outcome. Common columns include gender, senior citizen status, contract type, payment, and churn. Survey data must be checked for completeness and interpreted carefully to avoid incorrect conclusions. Beginners often mix up column meanings or forget to handle missing answers, leading to misleading insight. Running the cell now. Let us start by loading a real customer satisfaction survey dataset so we can practice analyzing survey responses. We fetch the dataset from OpenML using its unique identifier. We extract the main data in data frame format for easy manipulation. We display the number of rows and columns to get an overview of dataset size. We look at the first 3 rows to see sample customer survey records. Running the cell now. The dataset has 7,043 rows and 20 columns, reflecting detailed customer profiles and their satisfaction outcomes. Notice key demographic columns like gender and senior citizen, alongside service and payment details, all crucial for analyzing churn patterns. This initial view confirms the data's scope and complexity, emphasizing the importance of understanding each column's meaning before drawing conclusions. Practice. Try printing the column names of the dataset. YouTube. For more tips, search for data analysis with Python market research. Now we will demonstrate how to access a subset of customer records using basic list slicing. We convert the data frame to a list of dictionaries, where each dictionary is a customer's record. We take only the first 5 customers from the list using slicing syntax. We print the resulting 5 dictionaries to view the sample records. Running the cell now. Here, the code converts the data frame to a list of customer dictionaries and selects the first 5 records. Notice how each dictionary contains key demographic and service columns like gender, tenure, contract, and churn status, giving a snapshot of diverse customer profiles. This step highlights how to access raw data entries before any analysis, emphasizing the importance of understanding the data structure in its original form. In market research, slicing allows you to focus analysis on customer samples before scaling up to the whole dataset. Separating out a specific attribute often speeds up analysis and groupings. We use list comprehension to extract the gender value from every customer record. We print the first 10 gender entries to verify our list. Running the cell now. Here, the code extracts the gender column from the customer dataset into a list and prints the first 10 entries. Notice the list contains a mix of female and male values, reflecting the binary gender categories recorded for these customers. This simple extraction helps beginners focus on one column at a time, which is essential before analyzing survey data thoroughly and ensures clarity when checking for missing or unexpected values. You can use this approach to prepare lists for calculations like counting or aggregating. Let us use a dictionary to count how many customers fall into each gender category. We initialize an empty dictionary to store counts. For each gender in the list, we check if it is already a key. If not, we add the gender with a starting count of 1. Otherwise, we increment the count for that gender. We print our dictionary with gender as keys and counts as values. Running the cell now. This output shows the count of customers by gender, with slightly more males, 3,555, than females, 3488, in the dataset. Notice how the code manually tallies each gender using a dictionary, reinforcing the importance of accurately aggregating categorical data. This exercise helps beginners understand basic data counting before moving on to more advanced tools. Now you have summary statistics using a dictionary. This pattern applies to many customer attributes. Let us move beyond manual counting by defining a function for reusable analysis. We create a function that takes list of records and returns the percent of senior citizens. Total is simply the number of records. We count seniors where the field senior citizen is 1. Percentage is calculated and returned. We apply the function to all customer data. We print the result as a percentage, clearly showing our finding. Running the cell now. This output shows that 16.21% of the customers in the dataset are senior citizens. The code calculates this by counting rows where the senior citizen column equals 1, then computing the percentage of such records relative to the total. This helps us understand the dataset's demographic distribution and ensures we're accurately interpreting key customer segments before further analysis. Using functions makes your analysis more flexible. Try modifying the function to analyze other customer attributes. Filtering is at the core of segmentation. Let us write a function to extract only churned customers. We define a function that keeps only those records where churn is yes. We use the function to get a list of departing customers. We display the number of churned customers to measure risk. Running the cell now. This output shows there are 1,869 customers who have churned, identified by filtering the dataset with a function and list comprehension. Notice how the code isolates only those records where the churn column equals yes, illustrating a fundamental data filtering step essential for focused analysis on at-risk customers. This reinforces the importance of correctly interpreting column values to avoid including unintended records in your insights. Business Insight, filtering customers by churn status helps target retention strategies or discover churn drivers. Segmenting departing customers by contract type often reveals churn patterns. We write a function that groups records using contract type as the key. We start with an empty dictionary. We loop through records to check their contract. If the contract type is not in our dictionary yet, we create a new list for it. Then we add the record to the list for its contract. When finished, the dictionary has contract types as keys with lists of customers as values. We apply the function to the churned customers only. For each segment, we display how many customers churned with that contract type. Running the cell now. This output shows how churned customers are distributed across different contract types, highlighting that the majority, 1,655 customers, are on month-to-month contracts. Notice the sharp contrast with much lower churn in longer contracts, which suggests contract length strongly influences customer retention. This segmentation helps illustrate the importance of breaking down data by key columns to uncover meaningful trends in churn analysis. Identifying segments with high churn rates can prompt product improvements or targeted retention offers. Grouping by an attribute and computing averages is powerful for tracking customer lifecycle trends. We define a function to compute mean tenure for each gender group. We prepare an empty dictionary to hold lists of tenure. For every customer, we assign their tenure to the correct gender bucket. If the gender is new, we initialize a list. We append each tenure value to the right list. After filling the groups, we calculate averages using numpy's mean function. Our final dictionary gives average tenure per gender. We apply the function to all customers. We print out the resulting averages by gender. Running the cell now. This output shows the average customer tenure grouped by gender, revealing similar values around 32 months for both females and males. Notice how the code used a dictionary to collect tenure values per gender before calculating the mean, illustrating an efficient way to summarize data by groups. This approach helps beginners understand how to aggregate and compare key metrics across categories without mixing up columns or missing data. Now try adding more segmentation variables or changing the grouping to contract type for deeper insights. Let us identify high-value customers based on monthly charges. We use a list comprehension to select customer records with monthly charges greater than 80. We show how many matching customers we found by displaying the count. We preview the first two high-value customer records. Running the cell now. This output shows that we identified 2,666 customers with monthly charges above $80, highlighting a high-value segment important for targeted analysis. The displayed dictionary samples reveal diverse profiles, including contract types and service usage, emphasizing why filtering by key columns like monthly charges helps focus on significant customer groups without losing critical detail. This step is crucial for exploring patterns linked to higher spending and potential churn risks. Practice, change the threshold or try using total charges instead of monthly charges. Reusable functions make it much easier to repeat core calculations across different variables. We create a summary function for any categorical variable, such as contract or payment method. We start a counts dictionary to gather counts. For each record, we check its value for the selected key. If missing, we initialize, otherwise, we increment the count. After populating, we add up the counts to get the total. Finally, we make a dictionary that gives both the count and the percent for each category. We return our formatted summary dictionary. We apply our function to summarize contracts among all customers. The summary shows the distribution and percentage for each contract type. Running the cell now. This output shows the distribution of customers by their contract type, revealing that over half have month-to-month agreements, while the rest are split between 1- and 2-year contracts. Notice how the summary not only counts each category but also expresses those counts as percentages of the total, making it easier to compare proportions. This aligns with the lesson's goal of creating reusable code to accurately interpret key categorical variables in the survey data. Try applying this pattern to different attributes, such as payment method or gender, for robust business reporting. Mapping categorical survey answers to numeric codes is essential for most calculations. We set up a mapping dictionary to represent churn as 1 for yes and 0 for no. We use a list comprehension and get method to recode answers in a new numeric list. We display the first 10 numeric results for confirmation. Running the cell now. This output shows the first 10 values of the churn column converted from yes/the no strings to numeric ones and zeros, using a mapped dictionary. Notice how this transformation simplifies analysis by enabling calculations like averages or modeling, but also watch for any missing or unexpected values that the code handles here by assigning nan. This step is crucial for making categorical data usable in machine learning or statistical tests while maintaining clarity on what the numbers represent. This transformation enables statistics such as churn rates or machine learning predictions. Cross-tabulation allows you to compare two factors side by side, like gender versus churn. We initialize an empty dictionary for our cross-tabulation. For each customer in the list, we retrieve gender and churn status. If the gender is new to our table, we initialize it. If the churn status is new for that gender, we set its count to 0. We increment the count for the relevant gender churn pair. After all records, our dictionary lets us view both gender and churn jointly. We print the cross-tabulated results for business interpretation. Running the cell now. This output shows a nested dictionary counting customers by gender and churn status, revealing similar churn rates among females and males. Notice the structure: the top-level keys are genders, and nested keys show counts of yes or for no churn responses. This crosstab helps us explore churn patterns split by gender, emphasizing the importance of organizing survey data to avoid misinterpreting combined statistics. With this analysis, you can spot patterns in churn across gender that could suggest new questions for customer research. Generalizing grouping and metric calculation opens the door to flexible analytics. We define a function that takes any group field and a custom metric function as arguments. We loop and split customers into groups based on the selected field. We append each record into its group. Finally, we compute the metric for every group using the function provided. The summary dictionary captures results per group for business evaluation. Below, we define a function for average monthly charge. We use our flexible aggregator to show average monthly charges by contract type. We print the results so financial trends by contract are clear. Running the cell now. This output shows the average monthly charges grouped by contract type, revealing that customers on month-to-month plans tend to have slightly higher charges than those on longer-term contracts. Notice the key insight here: grouping by contract helps us compare spending patterns across customer segments. This approach demonstrates how custom aggregation functions can uncover meaningful differences beyond simple counts or sums. Now you can easily swap in different metrics or segmentation fields for in-depth exploration. For actionable insight, combine multiple criteria and summarize the profile of specific customer segments. We define a function that filters to churned customers with both high charges and low tenure. We extract all such high-risk customer records for profiling. We reuse our category summarizer to check which contract types are most at risk. We print out the high churn, high-value contract segments for business response. Running the cell now. This output highlights that nearly all high-risk churn customers, those with monthly charges over $70 and tenure under 12 months, are on month-to-month contracts. The code's intent is to identify vulnerable segments, showing month-to-month contracts dominate high churn profiles, which helps target retention efforts effectively. Notice how combining multiple filters in the function refines the customer subset for clearer insights. This multi-step approach replicates real-world reporting pipelines for customer risk analysis. It is common practice to save your market research insights for sharing. We open a text file for writing, where our summary will be stored. For each contract group, we write the average monthly charge to the report. Then, for each high-risk contract, we write out its risk statistics. Our file is now ready for business presentation. Running the cell now. Now opening the generated summary report file so you can review market research results. Try developing your own reporting functions that save insights in more complex formats. Market research data often has blanks or missing responses that need to be identified. We count how many customers have missing or blank total charges using Dictionary Get. We print out the result to flag potential data issues. Running the cell now. This output shows that there are no missing values in the total charges column, indicating the dataset is complete for this key numeric feature. Noticing 0 blanks here is important because it means we can safely analyze charges without needing to impute or drop missing data. This step helps ensure our insights about customer charges and satisfaction remain accurate. Business insight: high rates of missingness in a key financial field often indicate operational or data entry issues. Beginners sometimes misspell a field name, leading to errors. Let us catch that. We try to access a non-existent field using a try-except block. If the field does not exist, we prevent a crash and set value to none. We print the result, which should be none, showing robust error handling. Running the cell now. This output shows how the code safely handles looking up a non-existent column, invalid field, by returning none instead of causing a crash. Notice that using a try-except block here prevents errors when accessing unexpected or missing keys in the customer records. This demonstrates an important lesson: robust data processing must anticipate and gracefully manage missing or incorrect columns to avoid interrupting analysis. Tip: always check available columns and handle missing data gracefully for reliable customer analytics. Misreading the response scale leads to incorrect market conclusions. Let us check for invalid NPS survey scores. We write a function to identify survey scores outside the expected scale, 0 to 10 for NPS. We create a list of NPS scores and flag any invalid values. If values are invalid, we print a warning message, otherwise we confirm the data is in range. For reproducibility, we set the random seed so results are stable. We generate some sample NPS values, including values out of range by design. We check and print the validation outcome. Running the cell now. This output highlights the importance of validating survey responses, like Net Promoter Scores, NPS, which should only range from 0 to 10. The code detects and warns that two values fall outside this valid range, signaling possible data entry errors or misinterpretations. This step is crucial in the lesson to ensure analysis uses clean, meaningful satisfaction scores and avoids misleading conclusions. Business insight: always verify your data meets the survey's defined scale before reporting aggregate results. Best practices in market research with lists, dictionaries, and functions. Use clear segmentation functions to compare trends across groups. For cross-tabulations, nest dictionaries for each factor, such as contract type by churn. When making a trend index, combine counts and percents to explain both magnitude and risk. For scoring, convert text responses or yes or no into numerical indicators early. Trend analysis often needs results stored in a list for ordering, and summary dictionaries for business reporting. Running the cell now. Let us run a full problem, estimate churn risk for new customers on monthly contracts. We filter our customers to only those with a monthly contract. We define a simple risk metric: a customer is risky if charges are above 75 and tenure under 6 months. We make a new list encoding risk for each customer. We calculate the risk rate as a percentage among monthly contract customers. We print the final churn risk estimate for easy reporting. Running the cell now. This output shows that 9.4% of monthly contract customers fall into a high-risk churn segment, defined by high monthly charges and short tenure. Notice how the code uses a clear, simple risk metric function to segment and quantify churn risk within a specific contract group, illustrating best practice in combining business logic with straightforward calculations. This concise risk rate helps prioritize customer groups for targeted retention efforts. This end-to-end pattern lets you go from messy survey data to business-ready performance or risk numbers. YouTube: to deepen your skills, search YouTube for Customer Analytics Python tutorial.